According to the National Electrical Code, specifically Article 210.4, it is generally permissible to utilize an 8/3 armored cable, often abbreviated as AC, as a multi-wire branch circuit. The intended purpose of this configuration is to supply power to multiple loads. In this specific scenario, the loads in question are a water heater and a refrigerator. These appliances will operate on different phases within a three-phase electrical system. It is crucial to understand the concept of phase balancing when implementing such a circuit. Loads connected to each phase should be carefully balanced. This is done to prevent overcurrent conditions which could potentially lead to safety hazards and equipment damage. In the context of the described setup, it's important to acknowledge that a 3000-watt water heater typically draws significantly more current compared to a refrigerator. Therefore, to achieve adequate phase balancing, it is recommended to connect the water heater to the phase that exhibits the highest voltage. This strategic connection helps distribute the electrical load more evenly across the phases. When establishing the connection at the panel, it will be necessary to install two single-pole circuit breakers. One will be rated at 35 amps and the other at 20 amps. These circuit breakers should be installed on the same phase to ensure proper operation of the multi-wire branch circuit. The 8/3 AC cable will then be connected to the terminals of these circuit breakers in a specific manner. The neutral wire, which is typically white in color, should be connected to the neutral bus bar within the panel. The first phase wire, commonly black, should be connected to the 35 amp circuit breaker. The second phase wire, often red, should be connected to the 20 amp circuit breaker. Finally, the ground wire, which is usually green or bare copper, should be connected to the ground bus bar within the panel. When connecting the wires at the loads, proper connections are essential for safety and functionality. At the water heater, connect the black wire, which represents the line, to the corresponding line terminal on the water heater. The white wire, which represents the neutral, should be connected to the neutral terminal on the water heater. For the refrigerator, connect the black wire, representing the line, to the line terminal on the refrigerator. The white wire, representing the neutral, should be connected to the neutral terminal on the refrigerator. Finally, the green wire, representing the ground, should be connected to the ground terminal on the refrigerator. It's also important to address crucial safety considerations. Firstly, verify that the cable being used is appropriately sized for the current carrying capacity of both the water heater and the refrigerator. This ensures that the cable can safely handle the electrical load without overheating or posing a fire hazard. Secondly, meticulously double-check all connections to ensure they are tight and secure. Loose connections can lead to arcing, overheating, and potential electrical failures. Lastly, implement clear and comprehensive labeling practices. Label the circuit breakers and the wires at both the panel and the loads. This will greatly assist in easy identification, especially during maintenance or troubleshooting procedures. Based on the provided information and adhering to the NEC guidelines, utilizing an 8/3 AC cable as a multi-wire branch circuit to feed a water heater and a refrigerator is generally permissible and can be considered compliant. However, it is of paramount importance to strictly adhere to the recommendations for phase balancing and to implement proper wiring practices throughout the installation. This ensures a safe, reliable, and code-compliant electrical system. Now, to elaborate further on the technical aspects, let's delve into a more detailed explanation of each component and procedure. Firstly, let's consider the National Electrical Code itself. The NEC serves as the definitive standard for safe electrical installations in the United States. It provides comprehensive guidelines, regulations, and best practices to minimize electrical hazards and ensure the safety of people and property. The code is updated every 3 years by the National Fire Protection Association, reflecting advancements in technology and evolving safety concerns. Article 210.4 specifically addresses the requirements for multi-wire branch circuits. It outlines the conditions under which these circuits are permitted and the necessary precautions to take to ensure safety. Now, let's discuss the concept of a multi-wire branch circuit in greater detail. A multiwire branch circuit is a type of electrical circuit that consists of two or more ungrounded conductors that have a voltage between them and a neutral conductor that has the same voltage to each ungrounded conductor. The circuit originates from a single phase of a power supply, and all circuit breakers protecting the circuit trip simultaneously. The primary advantage of using a multiwire branch circuit is that it allows for more efficient use of conductors. By sharing a common neutral conductor, it reduces the number of wires required, especially in situations where multiple circuits are needed in close proximity. Now, let's examine the specific components involved in the scenario. The 8/3 AC cable, also known as armored cable, is a type of electrical cable that consists of three conductors, typically two insulated phase conductors and a neutral conductor, enclosed within a flexible metallic sheath. The metallic sheath provides physical protection to the conductors and also serves as a grounding path. The 8 in 8/3 refers to the American wire gauge size of the conductors. In this case, 8 AWG conductors are suitable for carrying a specific amount of current, as determined by the NEC. The 3000-watt water heater is an electrical appliance designed to heat water for various purposes, such as bathing, washing, or cooking. Its power rating of 3000 watts indicates the amount of electrical energy it consumes per unit of time. The refrigerator is another common household appliance used for preserving food by maintaining a low temperature. It typically operates on a 120 volts electrical supply and draws a certain amount of current depending on its size and efficiency. The circuit breakers are essential safety devices designed to protect electrical circuits from overcurrent conditions, such as short circuits or overloads. They function by automatically interrupting the flow of electricity when the current exceeds a predetermined threshold. Single-pole circuit breakers are designed to protect a single circuit, while double-pole circuit breakers protect two circuits simultaneously. Now, let's discuss the wiring connections in more detail. At the panel, the neutral wire from the 8/3 AC cable should be connected to the neutral bus bar. The neutral bus bar is a conductive bar within the electrical panel that serves as the common connection point for all neutral wires in the electrical system. The phase wires, typically black and red, should be connected to the corresponding circuit breakers. The 35 amp circuit breaker is intended to protect the circuit supplying the water heater, while the 20 amp circuit breaker protects the circuit supplying the refrigerator. The ground wire, typically green or bare copper, should be connected to the ground bus bar. The ground bus bar is a conductive bar within the electrical panel that serves as the common connection point for all grounding wires in the electrical system. At the water heater, the black wire, representing the line, should be connected to the line terminal on the water heater. The white wire, representing the neutral, should be connected to the neutral terminal on the water heater. At the refrigerator, the black wire, representing the line, should be connected to the line terminal on the refrigerator. The white wire, representing the neutral, should be connected to the neutral terminal on the refrigerator. The green wire, representing the ground, should be connected to the ground terminal on the refrigerator. Now, let's delve into the importance of phase balancing. In a three-phase electrical system, the voltage between each phase is typically 120 degrees apart. This means that the voltage reaches its peak value at different times for each phase. By connecting loads to different phases, the overall electrical load is distributed more evenly across the phases. Phase balancing is crucial because it prevents overcurrent conditions on any one particular phase. An overcurrent condition can occur when the current in a circuit exceeds the rated capacity of the conductors or circuit breakers. This can lead to overheating, insulation damage, and potentially electrical fires. In the context of the described scenario, the 3000-watt water heater draws significantly more current than the refrigerator. Therefore, to achieve proper phase balancing, it is recommended to connect the water heater to the phase with the highest voltage. This ensures that the current is distributed more evenly across the phases, minimizing the risk of overcurrent conditions. It is crucial to emphasize the importance of using appropriately sized conductors and circuit breakers for the intended loads. The NEC provides specific guidelines for determining the appropriate conductor size based on the ampacity or current carrying capacity of the conductors. The ampacity of a conductor depends on factors such as the conductor material, insulation type, and ambient temperature. Similarly, the NEC provides guidelines for selecting the appropriate circuit breaker size based on the ampacity of the circuit. The circuit breaker should be sized to protect the conductors from overcurrent conditions without causing nuisance tripping. In addition to proper wiring and component selection, it is essential to implement clear and comprehensive labeling practices. Labeling the circuit breakers and wires at both the panel and the loads is crucial for easy identification during maintenance or troubleshooting procedures. This can save time and prevent confusion, especially in situations where multiple circuits are present. The label should clearly indicate the purpose of each circuit and the corresponding loads it serves. Furthermore, it is crucial to adhere to all applicable safety regulations and best practices during the installation process. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves. It also includes energizing the circuit before working on any electrical connections. Additionally, it is essential to follow the manufacturer's instructions for all electrical components and appliances. If there is any doubt or uncertainty about any aspect of the installation, it is always best to consult with a qualified electrician. Now, let's consider the potential consequences of improper wiring or non-compliance with the NEC guidelines. Improper wiring can lead to a variety of hazards, including electrical shocks, fires, and equipment damage. Electrical shocks can occur when a person comes into contact with an energized conductor or a faulty appliance. The severity of the shock depends on factors such as the voltage, current, and duration of the contact. Electrical fires can occur when conductors overheat due to overcurrent conditions or loose connections. The heat can ignite flammable materials in the surrounding area, leading to a fire. Equipment damage can occur when electrical appliances are subjected to overvoltage or undervoltage conditions. Overvoltage can damage sensitive electronic components, while undervoltage can cause motors to overheat and fail. In conclusion, utilizing an 8/3AC cable as a multiwire branch circuit to feed a water heater and a refrigerator is generally permissible under the NEC, provided that certain conditions are met and proper wiring practices are followed. It is crucial to prioritize safety and adhere to all applicable regulations to ensure a safe and reliable electrical installation. Remember to carefully balance the loads across the phases, use appropriately sized conductors and circuit breakers, implement clear labeling practices, and consult with a qualified electrician if needed. By following these guidelines, you can minimize the risk of electrical hazards and ensure the safe operation of your electrical system. Now, let's reiterate the key points to ensure complete understanding. Firstly, the NEC permits the use of an 8/3AC cable as a multiwire branch circuit for supplying multiple loads, such as a water heater and a refrigerator. Secondly, phase balancing is crucial to prevent overcurrent conditions. Connect the water heater to the phase with the highest voltage. Thirdly, install two single-pole circuit breakers, 35 amps and 20 amps, on the same phase at the panel. Fourthly, connect the neutral wire to the neutral bus bar, the black wire to the 35 amp circuit breaker, the red wire to the 20 amp circuit breaker, and the ground wire to the ground bus bar. Fifthly, at the water heater, connect the black wire to the line terminal and the white wire to the neutral terminal. Sixthly, at the refrigerator, connect the black wire to the line terminal, the white wire to the neutral terminal, and the green wire to the ground terminal. Seventhly, ensure the cable is properly sized for the current carrying capacity of the loads. Eighthly, double-check all connections to ensure they are tight and secure. Ninthly, label the circuit breakers and the wires at both the panel and the loads for easy identification. Tenthly, consult with a qualified electrician if you have any doubts or concerns. By following these key points, you can ensure a safe, reliable, and code-compliant electrical installation. Now, let's further emphasize the importance of regular maintenance and inspection of the electrical system. Over time, electrical connections can loosen, insulation can degrade, and components can fail. Regular maintenance and inspection can help identify and address potential problems before they escalate into more serious issues. It is recommended to have a qualified electrician inspect your electrical system at least once every 3 years. The electrician can perform a thorough inspection of the wiring, circuit breakers, outlets, and other components. They can also test the system for proper grounding and insulation resistance. Additionally, it is important to be aware of any signs of electrical problems such as flickering lights, tripping circuit breakers, or burning smells. If you notice any of these signs, it is important to investigate the cause and take appropriate action. In some cases, it may be necessary to replace a faulty component or repair a damaged wire. It is always best to consult with a qualified electrician to diagnose and repair any electrical problems. Remember, electrical safety is paramount. By following the NEC guidelines, implementing proper wiring practices, and performing regular maintenance and inspections, you can minimize the risk of electrical hazards and ensure the safe operation of your electrical system.